Hello everyone. This is the second part of the planning video which I'm doing. So for this part of the video, we are going to focus on a particular experiment to further illustrate how the planning can be broken up into very basic process. So in this video, I'm just going to take one of the lens experiment which we have done, and the lens experiment that we are going to take is this. Right over here, I've shown you the setup, and this is the front page of your practical assignment. So just to let you know, this is the practical which I'm going to use to illustrate planning process. Now, for now, you're given this experimental setup, and this is the equation which you are given in the question. Now, before you begin describing the experiment, you must first conduct an analysis first. And from here, what you're trying to do is to elicit as much information as possible from this equation. Only then can you proceed on with the planning. What you're given here is, well, you have three reciprocals, or maybe three fractions, put inside an equation. And all of us know that, well, mathematically, fractions are not the friendliest things to manipulate with. So what we are going to do is we're going to try to take this equation and manipulate it into something that we are all familiar with. And what we are familiar with is this: y equals mx plus c. I say again, we are now conducting an analysis to try and elicit as much information as we can from this equation. If we can manipulate it into y equals mx plus c, we will end up with a straight line, and a straight line is always easier to analyze than a curve. So from the equation, 1 over f equals 1 over u plus 1 over v. Right. Now, we know that 1 over f, this is the focal length. Okay, this is the focal length of the lens. And because this is the focal length of the lens, we know this will remain constant. But do note, this is not a constant quantity. This is not a constant quantity. Mathematically, we know this value is going to remain constant. This is the object distance, and this is the image distance. If you are not able to recall all these things, I suggest you pick out the practical worksheet and start reading through first before you continue with this video. Now, from this equation, I'll rewrite again 1 over f equals 1 over u plus 1 over v. Okay, we're going to manipulate it to something that we know. So on the left side, we have a constant, and on the right side, we have an independent variable and a dependent variable. That's a u and a v. So what I'm going to do, for y equals mx plus c, we know y has to be the dependent. So we're going to flip the equation the other way around. And this is what I meant: 1 over u plus 1 over v equals 1 over f. And we know that in the y equals mx plus c, x is the independent variable. So 1 over v is a dependent variable. We keep it on the right side, on the left side. And so 1 over u is the independent. We shift it to the right. And minus 1 over u is actually minus 1 times 1 over u. And then we have it, y equals mx plus c, where y equals 1 over v, x equals 1 over u, m equals minus 1, and c equals 1 over f. And the m is the gradient, and the c is the y-intercept. There you have it. From the graph, we can actually obtain focal length of the lens. And this is what information this is the kind of information that we will get. So coming back here, so from the equation, we can tell f is the focal length, right? That's because we are using the same lens throughout the whole experiment. So in a way, focal length will remain constant. And when focal length remains constant, 1 over f also remains constant. But do know that f is not a constant quantity, because no matter how you change u, f is not going to change at all. The quantity that is to remain constant is something which you need not only measure it, but you have to put in effort to make sure that it remains constant. So for the u and v, one is the object distance, and the other is the image distance. Now note, during the practical itself, see here, you measure and record the object distance first. Then you measure and record the image distance v. So you measure u first, and then you measure v. And the steps are put in this way because v depends on u. V depends on u, as I stated here. And because v depends on u, that makes v the dependent variable and u the independent variable. So v depends on u. And note that in this practical, there are no constants. So we look back at the questions, we didn't ask for any constants. So also note again, the formula is 1 over f equals 1 over u plus 1 over v. So other than u and v, we will need to calculate and tabulate 1 over u and 1 over v. And when we manipulate the equation, we get this. So using the manipulated equation, we can deduce a type of graph to be drawn, and that is 1 over v against 1 over u. And I emphasize again, this is y equals mx plus c. And that makes this y, and this is x. And therefore, it has become a graph of 1 over v against 1 over u. And when that happens, your gradient is -1 and your y-intercept is 1 over f. So as of now, we already map out all the analysis. And not to worry, right? Now this video seems very long, but I assure you that with more practice that comes along, this process should get shorter and shorter. Don't worry too much about it. Right, so by now the analysis are all mapped out. Next, we want to pan out all the processes. And I'd like to emphasize again, although we need to pan out the processes and some of the steps can be repeated from what has been given, please do not copy the entire experiment word for word. You have to reread the question and see what they asked for in the first place. So in the next part of this video, I'm going to show you how it's done.